MANagement project aims at delivering a digital tool able to dynamically predict wildfire risks in rural areas where telecommunication infrastructures are located. The main idea behind it is that infrastructure manager, owner, or even first responders could actually intervene as soon as possible and in this way avoid any interruption of service of the infrastructure or any damage for it. Project's main innovation consists in delivering continuously, especially high-resolution maps of wildfires on the area of interest, which is the central part of Italy. And in order to do so, MANagement concept relies on the use of satellite images taken from several sources and state-of-the-art deep learning methods. Combining these ingredients all together allowed us to develop an AI-based forecast engine that allowed us to predict wildfire maps on the area of interest with a quite high spatial resolution, around 500 meters. Atop of it, we developed a thermal anomalies mapping service that served somehow the trained model for showing predictions every day. So in order to do all these things, we faced actually many challenges. The first one was choosing which data were actually most suitable for feeding the neural network. After a comparison of all data available for this task, we actually chose 3 types of data. Surface soil moisture, taken from AI4Copernicus services, soil temperature level at 2 meters, again taken from Copernicus services within the ERA5 reanalysis initiative, and the thermal anomalies maps from MODIS, a NASA satellite. Gter, one of the partners of the project, developed the data preprocessing chain in order to make all this data coherent with each other and suitable for feeding them into the neural network. The second challenge we had to face was choosing which architecture of the neural network was the best one for us, for the project requirements. And we explored 2 types of architectures. The first one is called COMB-LSTM. A COMB-LSTM is based on a long short-term memory unit, but instead of using a conventional matrix multiplication in it for all the computational operations, we use convolution. The second architecture explored for this project was the broad UNet, which is a kind of UNet-based model, UNet-based neural network, specifically designed for nowcasting tasks. And we tested both architectures on a test bed dataset, the MNIST dataset available online, and we found out that the broad UNet outperforms the COMB-LSTM. So the latter, the first one, the broad UNet, was the neural network model that we choose within the project. Okay, once the data were available and architecture was chosen, we actually had to train the model with the data downloaded and available. And this was maybe the main challenge we faced because the dataset were pretty had a very big size, and therefore we had to use an ad hoc infrastructure, computing infrastructure for training the model. Eventually, we ended up with a virtual machine with GPU acceleration and 32 gigabyte of RAM. Even with that virtual machine, we couldn't train the model using the whole dataset just once, but we had to adopt transfer learning techniques. However, eventually we ended up with a fully trained model that we tested on the validation and test dataset based on historical data. Once the model was trained, we developed the thermal anomalies mapping service around it. This was maybe the most important part of the project because we made available the model and moreover we developed a software, we developed a service that could continuously generate predictions at a daily basis. This mapping service consists in two main parts. The first one is a near real-time pipeline that every day downloads the latest available data, pack them together and feed them into the neural network in order to generate a new prediction. And the other one is a web application that show the latest prediction computed. For all the work carried out within the S.r.l project, we would like to thank the AI4Copernicus Consortium and all the partners. This work wouldn't have been available without them, and it was a great adventure for us to develop the S.r.l thermal anomalies mapping service.